you could do it. I don't know why you would want to do it, but you could do it. You could just make a matrix out of this and go 2 times and select matrix A. And it would spit that out for you. Now, most of you guys, it would be a whole lot easier to just go 2 times every number and get it. So this becomes A prime, B prime, and C prime. So you can use a matrix to do that. It's totally up to you. Okay? You can use a matrix to reflect. So if you look, go ahead, and they only do it, let's see, they do it on page 507. Go ahead and open your book to page 507. I don't know why you would do this either, but. The only thing I would use a matrix for would be rotation, in all honesty. Okay, 507. See in the middle of page 507 where it says reflection matrix? Okay, now do you remember the thing about multiplication, that there's order to multiplication with a matrix? If I am multiplying 2 by 3, if I have a 2 by 3, then what I'm multiplying it by has to be a 3 by something. So all of these, if I have a triangle and I have something like this, these reflection matrices have to be placed in front of those. So if I wanted to reflect it over the x-axis, I could multiply this matrix by 1, 0, 0, negative 1. If I put that in like under matrix A, that in under matrix B, and just said select matrix A times matrix B, it would give me the result. Okay? Now, I can tell you what it's going to give you because it's over the x-axis, so what's going to change? The y value. The y value is down here. It's going to give me 4, negative 2, 5, negative 4, negative 2, negative 7. Now, I don't know why you would put that in your calculator and do that. It would be harder for me to remember that matrix than what it would be to remember that I'm just changing the sign on my y. But it can be done that way, okay? It's doable that way. It's okay that way. Notice there's a y matrix, there's an origin matrix, and there's a y equals x matrix. To me, it's so much easier just to go, wait a minute, I'm reflecting it over my x, so therefore my y value changes. Or remember what happens when you have y equals x, what happens? You switch the two of them. Now it's easier for me to remember those rules that I had for reflection than what it would be to remember those 4 matrices. Okay, that's my personal opinion. You can, however, do it with a matrix. All right? So that's a second way of using the matrix. This would be reflection. The other one was dilation. What about translation? Let's say we have this matrix and we want to move it 3 to the right and 2 down. Okay? Now, what are my x values on these? Is it the top or the bottom? The top. So what I do is I make another matrix that I'm going to add to it. And on every x value, I'm going to put the 3. On every y value, I'm going to put the negative 2. If I put those 2 matrices in my calculator and added them, my resulting matrix would be my new values. Does that make sense? Now, again, don't know that I would go through the headache of it. Because I can just add 3 to my 4 and know that's going to be a 7. I can add 3 to the 5, 3 to the negative 2. Very quickly, I could get what I needed to get without going through all the headache of putting the matrix into my calculator. Okay, I'm not trying to talk you out of using them. I'm just saying, I feel like the simpler way is the way that we've been doing it.
Yeah.
Okay, that you can use a matrix for it, but you don't have to. Now, I will convince you on a rotation, use the matrix, because you do not want to do that stuff, okay? For one thing, and I didn't even point this out, when you measure up like 9.5 and you measure 60 degrees, how do you find the exact location of that? I mean, how do you find the ordered pair that is? So it's very impractical versus what we're about to do, okay? Real important, look on page 508. These are rotation matrices, okay? These are so important. If I were you, what I would do is I would put them in my calculator, and I probably would jump on down to maybe things that I wouldn't use, like, I don't know, S, T, and U. And on S, I would put the 90 degree. On T, I would put the 180. And on U, I would put the 270. And I would leave them in my calculator. And know that I'm talking 90, 180, and 270. Now, the only thing that they give you here, these are counterclockwise. Okay? Now, I want to show you what happens. Let's say I want to move it 270 degrees counterclockwise. We're not going to worry about the clockwise ones, okay? So everything they're going to ask you about is counterclockwise. Let's say I want to take this matrix. This is my X, Y, X, Y, X, and Y. And I want to rotate it 270 degrees counterclockwise. So what I'm going to do is I'm going to put these two matrices in there. 0, 1, -1, and 0. And I'm going to multiply them. So I want you to do that right now. Okay? In fact, go ahead and do S, T, and U or somewhere down. Don't do A, B, C, or D because you're probably going to use that for something. So you just put a spot in your calculator. You put those matrices in, those rotation matrices. You understand what I mean? Okay. I'm going to go ahead and put the homework up here so that I can turn off the camera and we'll do the rest of this. Okay, did you do this one out?
So how do you multiply this?
Okay, literally select, okay, did you put both matrices in there?
Yeah.
Okay, so then come back here to second matrix. Okay, which one's under which?
Oh, I did.
Okay.
I did A for the coordinates and then J for the 217.
Okay. Okay, so select J
Mm-hmm.
times, and then go back here to second matrix, select A, then hit enter.
Oh,
Okay, you remember doing that?
yeah.
Okay, did you get it all the way through? Did you get the answer?
What was
What is it, Stephanie? 2, 4, 7, -4, -5, and 2.
No.
No. Okay, this is,
Oh wait, I did it by 90.
you did it by 90, you 70. Okay. All right, so here's what your homework is, okay? This is on dilations. Now, we did that one first, even though the rotations came first in your book. So this is your homework on dilations. That involves still graphing it, okay? That's like your homework for today. This one, there's just 3 on rotations, and that's going to involve, the rotations are going to be by way of reflection, and they're going to tell you what to reflect over. This last one, this is when they put it all together and said you could use the matrix on it. Now, there is no graphing involved in this. They just want to know your final points, okay? So you can do it all algebraically. Here's what I would suggest on this. Only use the matrix on your rotation, okay? If it says reflection, then just change your points to the opposite of what you have, depending on whether you're reflecting it over the X or Y. Does that make sense?
Yeah.
Okay, so there's not going to be, this is going to be done real quick, okay? It looks like a lot of stuff, but it's really not, okay? And I'll get the colored pencils out, so